We welcome you this morning to the first in the series of college seminars hosted by the College of Life Sciences here at BYU. I'm Merrill Christensen, professor in the Department of Nutrition, Dietetics, and Food Science, who is hosting today's speaker. Dr. John Milner is chief of the Nutritional Science Research Group, the Division of Cancer Prevention at the National Cancer Institute. He earned his bachelor's degree in animal sciences from Oklahoma State and his PhD from Cornell in nutrition with a minor in biochemistry and physiology. He served on the faculty for 13 years in the Food Science Department and in the Division of Nutritional Sciences at the University of Illinois Urbana-Champaign, where he also served as director of the Division of Nutritional Sciences and assistant director of the Agricultural Experiment Station. He then went to Penn State, where he was head and professor in the Department of Nutrition from 1989 to 2000. Dr. Milner is a member of several professional organizations. He is a member, president, chair, and advisory capacity to numerous governmental and professional committees, boards, and other organizations, including the Dietary Guidelines Committee, the Presidential Commission on Dietary Supplements, the U.S.
He's cutting into my time. You do know that.
I'll cut to the chase. The thing that recommends him most highly is that he has done selenium research. So he's here to talk about genomics. Now, to give you one further plug, this is the topic today. He will also, we're very grateful that his time allows him to spend tomorrow with us as well. He'll be speaking tomorrow on the subject of bioenergetics, obesity, and cancer. That's again at 11 o'clock over in the Iron Science Center, as you see there in C285. So let's give a warm welcome to Dr. Milner here at BYU.
To be here. You know, this is my first time at BYU, and wow, have I enjoyed this. This is nice, and what a nice turnout. You know, everything he said about me is true, but it really means one thing: I'm old. I've been around a lot. I'm here actually today to really talk to you about a topic that's near and dear to my heart. And I certainly appreciate the invitation to come here to share some thoughts with you. I'm going to show you a fair number of slides. And so if you'll copy down that email address, if you'd like copies of the slides, send me a note. More importantly, if you have better slides than I do, would you send them to me? Now, I have to make one statement before I say anything else. And that is that these are my opinions and not necessarily those of the National Cancer Institute. Now I've got a lot more freedom to say what I really believe, right? Okay, so, you know, I think many of us in the nutrition arena believe there are unprecedented opportunities for using diet for a whole host of things. Certainly to achieve that genetic potential. We're all endowed with some genes that will allow us to grow certain ways, certain height, and develop in a certain manner. And nutrients are fundamental to that process. But nutrients are more than that. They, in fact, can modify your overall performance. And that can be either physical or cognitive performance. And there's a wealth of data that is starting to emerge in that area, and I encourage you to do some reading in it because it's fascinating. And then the final area is that related to diet and health, and how, in fact, diet can modify your risk of several disease states, including cancer. The problem with all of this is that diet is not simple. In fact, there are about 25,000 bioactive food components in our diet. And so understanding which ones of those are most important and under what circumstances is an extremely daunting task. But we're making headway. We're understanding what some of those nutrients are doing and why they're doing it, and some of the important interactions. And I'll share some of those with you today. Well, as I said, diet is actually one of the leading causes of death of Americans, and it's also one of the leading causes of death worldwide. Actually, the major killers that occur in this country in various parts of the world are cancer and heart disease, and there's a tug of war going on as to who's in that leadership position. Cancer is going to win. And I'll show you a little bit more about that in just a few moments. But I wanted to show you this slide that tells you about where we are and where we're projecting we'll be in a few years down the road. How many millions of people we think we're going to lose as a result of cancer? About 10.3 million. Right now it's about 7.2 million. That's not too long down the road when we're going to lose a lot more people. If you look at that map closely, you'll notice some countries are going to have a rather massive increase in cancer risk, including the U.S., but it's not limited to the U.S. In fact, if you look at that map pretty closely, you'll see this is a global issue, and it occurs in what we would refer to as impoverished countries, suggesting that nutritional imbalances, deficiencies may also be key in causing an increase in risk. So it's not only overindulgence of calories, it may be some limitations in selected components that are increasing our overall risk. Why do we think that there's going to be an increase? Two primary factors. One, we are an aging society. We're all getting older, whether you like it or not, and I've been down that block more days than most of you. That, by definition, increases your risk of developing an aberrant cell. As well as that, we are a growing society. We are growing out, not necessarily growing up. An increase in obesity is associated with about a 20-25% increase in the risk of several cancers. I'll talk a little bit more about that tomorrow. It's not all cancers, but it's some, and there is a fair amount of variability in that. If you really look closely at that figure, though, you'll notice that, there's a pretty flat line for the early cancers that are occurring in children. But what we're really seeing is an increase as we age. And as I said earlier, we are an aging society. And so that's one of the primary reasons you're going to see it around the world. So if you start thinking about we're going to see an increased risk, then you have to say, wait a minute, how good is our therapy? Well, with some cancer sites, it's actually pretty good. With others, it's pretty dismal. I always say that if you prevent, you don't have to treat. And so the strategy that we should be working after is, can we develop effective strategies to minimize our risk of cancer? So, saying that, what is the evidence out there that diet's really important? It actually goes back to a paper that was published about 35 years ago by Pito that suggested that about 35% of our cancers relate to dietary habits. A third of your cancers could be eliminated by a proper diet. Wow, that's an interesting number, isn't it? It's a wishy-washy number, though. You know what? That number is probably as low as 0 and as high as 100%, depending on the diet that you eat and the type of tumor that you're talking about. Okay, but given that kind of number, I think it's pretty impressive, right? Now, why would I say that? Cigarette smoking is associated with about a comparable incidence of cancer, about 30-35%. When do you see advertisements on the TV or in the news? Do you see them about cigarette smoking? Do you see as many about diet? No, you don't. Why is that? Smoking is one factor. It is one with several hundred compounds, but not several thousand that I mentioned earlier. So it's exceedingly complex to deal with. And there's more to the story, as you might appreciate. Well, that early paper by Pito has been reconfirmed through basically a treatise that was published in 2007, late 2007, by the World Cancer Research Fund, the American Institute for Cancer Research. It basically documents there's about a 30-35% reduction. If you look at colorectal cancer, it's probably closer to 70%. If you look at, let's say, lung cancer, it might be closer to 20%. So again, that variation is in the document, and some sites are going to be much more responsive than others. If you haven't seen that report, go to it and look at it. It is the best compilation of information that we have about what is the evidence relating to diet and cancer. And it will give you some clues about eating behaviors, and I'll come back to that in just a few moments. Well, you know, when you gather data, noted by a scientist, Mark Twain, said, first you get the facts, then you distort them to your pleasure, right? Isn't that true? So now we've got a document, and then everybody and their dogs are going to look at that and say, wait a minute, I don't know about that. In fact, if you look at the document very closely about the relationship between eating behaviors and cancer risk, you notice up here at the top of convincing and the influence of diet increasing or decreasing risk, nothing. Wow. You wouldn't believe that when you came into this seminar. You wanted me to tell you diet is absolutely it. That is not there. There's some probables. Well, that dampens it, doesn't it? So the probables are probably because there's a lot of variability in the response that we see. So we have to start asking ourselves, why in fact is the data not more compelling? So I thought, you know, maybe what the best is to show you some data, then you can start trying to figure out what's going on here. So I picked one, I've actually picked two examples to quickly show you. One's soybean, the other one is tomatoes or lycopene. Soybeans has an active compound, actually has several active compounds, one's genistein. If you look at the totality of data that is out there on soy intake and breast cancer risk, you'll notice if you're the optimist, you love that study. It doesn't cross one, clearly an inhibitory effect. If you're the pessimist, you like maybe that study. It's on the other side of one, so now there's an increase, and there's lots of variability, so you say, I don't care about soybeans. You can get those conclusions based on the data that's in the literature. What we haven't done is actually look a little closer and say, oh, wait a minute, this is premenopausal, that's postmenopausal women. What we actually haven't also done is said, oh, these studies were in Asia as compared to these down here in the US. We also haven't said, wait a minute, some of these are with tofu and various other soy products and not with soybeans per se. We tend to lump everything together rather than trying to understand what's truly going on. Overall, if you look at soybeans, there's about a 20-25% reduction in breast cancer risk across all studies. But clearly from this you can see there's a lot of variability. Now, the same story holds if you're a guy and you're interested in reducing your risk of prostate cancer with tomatoes or lycopene. If you're the optimist, you like that study since it doesn't cross one. If you're the pessimist, you're over here. These are the issues. The press sends you out an article each day that says, hey, listen, this is what the next study showed, the last study showed, and then the next day you get this one. And then you're supposed to say, what am I supposed to do now? That's the problem we're facing. Well, part of the reason for this variability in response across people may well be that we in fact are comparing apples and oranges. That we are in fact are not identical individuals. That we need to understand individuality in response if we're truly going to make any sense out of what is the role of diet in cancer prevention. What that then means is that we need to understand you as an individual and understand how the omics influence that response. What that then means is that we need to look at your genes, or we refer to that as nutrigenetics. But we also need to look at epigenetic events, methylation, histones, etc. And I'll go into it in a few more details in a few moments. And we need to look at how those are transcribed, and so that transcriptomic profile becomes important. Those set the stage for proteins and metabolome, those small molecular weight compounds that influence. You know, life would be so simple if this was a linear response. It's not. And so what that means is you need information in each one of these categories to really predict what is the phenotypic outcome. Now, several years ago at NCI, we started talking about a very interesting term. It's called nutritional preemption. It basically says, if I know something about you, then I can intervene. That says, information about you based on this kind of information, or nutrigenomics. And so I'll share with you some information that I hope will prove this case to you. So I thought, what is the best way to prove my point? Is to give you a big example. This is one with calcium and colorectal cancer. Now I want you to look at those studies. There's 7 studies. Overall, you get, if you analyze all the data, somewhere around a 20-25% reduction in colorectal cancer in people who consume more calcium than people who are bottom feeders, as I call it, that don't drink milk or use calcium supplements, etc. All right? Now, that's based on this series of studies. It actually turns out, if you look at those studies, only one of them is significant. You know which one? That one. The one on the wrong side of 1. God. Now look at the variability in those. Doesn't it make you want to go right out and drink a big glass of milk? No. So you say, well, why could that be happening? And so part of the reason may be a gene polymorphism that is associated with the vitamin D receptor. This vitamin D receptor is sensitive to calcium intake in the diet and at least risk of colorectal cancer, potentially other side. When you have a gene variant that changes the protein that's now formed, a vitamin D receptor per se, and you have inadequate amounts of calcium in the diet, you get an increased risk of colorectal cancer. When you don't have that polymorphism, you do not see an increase when you have an inadequacy. Now that's interesting. So this is about 20-25% of the population. For about 75-80% of the population, it doesn't matter. But for a subset, it sure does matter. Now, this is only one study, and there are about 400 polymorphisms in this vitamin D receptor. So you can't always say all people are going to respond that have just this polymorphism, but it's a clear indication we might be able to go with some gene profiling to tell us about who needs to ensure they have adequate amounts of calcium in their diet. Now, is there any evidence that, in fact, this is important? You bet. It actually happens in children. It happens that when you have that polymorphism that was associated with increased risk, sorry, they moved over, then you have poor calcium accretion. It takes about 20-25% more calcium to give you the same bone health in children that have that polymorphism that I was showing you, increases your risk of colorectal cancer. And now you should be saying to me, so what? What does that have to do with colorectal cancer? And the answer is, I have no earthly idea. In fact, that's the problem. We need to now take that information and put it into a mechanistic standpoint and actually understand the process that is being modified. Now, these are cancer-related processes and they're all fundamental. Several years ago, we used to talk about credentialing. Which one of those processes is most important for inhibiting a tumor? Is it changes in inflammation or DNA repair or any of these others? Or is it in fact because nutrients are pleiotropic that it hits several of these? And most of us now are thinking, unlike drugs which have a specific target, nutrients are pleiotropic. They influence multiple sites. Now, one of the sites that is influenced by several nutrients is actually cellular differentiation. And I thought, I want to prove the point to you of why diet is so important and how you can misconstrue all kinds of things. And here's the example. It's actually in rodents. It was a very interesting study that was happen chance. This is a nice, interesting story because this is a differentiation model. This is actually associated with the Hox gene, which is overexpressed in cancer patients. It turns out in these cancer patients that have an overexpression of the gene, you get poor differentiation of bone. You know, you end up with metastases and all these kinds of weird things happen, right? So this lady was doing these fundamental studies with this Hox gene in Arizona. That's nice, right? She could show this gene was really important for the integrity of bone. She got a job. She got a job in Nebraska. Now, I think in Utah, you understand that's not that far away, right? But when she got over into Nebraska and she did her same studies, this is what the bone looked like in those animals. She said, wait a minute, I brought the animals with me. I just crossed the state line. I didn't do anything else. She did one other thing. She changed the diet. It actually turns out the diet fed to these animals was very high in folic acid, and it prevented the expression of that gene from occurring. That's what happens, I think, in us day in and day out. We don't necessarily cross borders, but we change our diet, and we just change the expression of genes. Now, one of the other cancer processes that is modified by nutrient is actually good old DNA repair. If you got exposed to some carcinogen, you want to get the stuff out of it. So there are a few studies out there, but not that many, that have actually examined the impact of diet. I want to share with this one with you because I think it's a proof of principle that, in fact, several foods can reduce the DNA damage caused by all kinds of carcinogens that we might be exposed to. The problem with this study is that there's no washout period between each of the foods that was intervened, and so you don't really know if there's a carryover effect or not. Do you realize that these studies were done in 6 or 8 people? You don't need thousands of people to do these studies, and they are fundamental to nutrition and food science. Well, speaking of DNA repair, we do know that there's a gene out there that is associated with DNA repair, and we know that it has a polymorphism. What's really interesting is some nice data that has come out in the last few years that actually suggests that people that have that polymorphism that increases risk and they consume tomatoes, they get the maximum benefit. But people who don't have that polymorphism don't really get that much benefit. Interesting. It's back to where I was. Your gene polymorphism set the tone for your response. And now we're getting closer to understanding the process that is being modified. Well, one of the other nutrients that has surfaced are phytoestrogens as modifiers of cancer risk. And I use this as a good example to say, you know, dose is important. Quantity determines whether you get a response or not. I wanted to particularly draw attention to this study. If you look at all of the individuals, and there were, I don't remember, there were about 2,000 individuals in this study. And you look at the dose response. That looks like there might be something going on there, but it's not statistically significant. And now if you start pulling out genes, you notice this group, there is a response, and there is a dose response. So again, I think we're going to be moving to a better definition of who is responsive, under what circumstances, and how much does it take to bring about a biological response. Well, one of the issues that was raised in the World Cancer Research Fund report was the intake of meat and how it might increase your risk of colorectal cancer. Invariably, we say those meat eaters, those people that eat meat 5 or more times a week, have about a 20% increase in colorectal cancer risk. Okay? Paul Harvey used to say, there's something else missing on that slide, so you're kind of saying something else. A little study done in France said, I wonder what happens if you look at some genes that are associated with the repair and detoxification of foreign compounds. They looked at some cytochrome P450 enzymes. And they said, let's draw a correlation with aberrations in those in the eating of meat. And the risk now, when you do that, is not 20%. It is now 50-fold. Now wait a minute. It's a study done in France, and so there are implications of this. So we're not all French, and so, Is that same thing true? Is it about a 5% incidence of this polymorphism here in Utah? I have no idea. But I want you to think back what I showed you earlier about the variation in response to foods. Remember the soy and the lycopene story? If, in fact, I vary the number of those sensitive individuals in the population I'm examining, I can end up with either a significant difference or a non-significant difference. Right? Now, 50-fold gets my attention, doesn't it yours? But wait a second. There's more to that story, isn't there? So if it's 5% of the population, does that mean that 95% of us, it doesn't matter? And what we should be doing is targeting that 5% who are vulnerable? I don't know the answer to that, but I think additional studies to verify this as an observation are going to be important things for us to consider. Is that a question?
Did you mean that the variants had all 4, all 6?
Absolutely, has all of these variants. So they had to look at a combination. So it's looking at multiple gene expression and the variation in those polymorphisms, so you can see them here.
If you have all 6, you're at heightened risk.
Absolutely. Actually, if you have a little less than that, it's still high, but not quite up to that 50-fold. That means we're going to build a data mount, doesn't it? I'll talk a little bit more about that tomorrow in the obesity story. All right. So the fundamental question, I think, is why would you even see this, and what is the process of being modified in that vulnerable group? And we really don't know the answer to that at this point. Now, just to prove, I'm talking too slow, I'm going to have to go a lot faster. So to make life more complicated and to go back to where I was earlier, diet is exceedingly complex. So if I actually do some animal studies and I look at the influence of red meat versus white meat, and I increase the quantity, I can see more aberrations in cells. And you know what? If I introduce some carbohydrates, complex carbohydrates, I reduce that risk. So it's not just meat, if there is a vulnerable factor. It is meat and no carbohydrates, or at least complex carbohydrates. Well, life would be so good if we could only have genes that improve our situation, not that cause increased risk. But I think we're going to find some genes out there that hold promise for benefits for some people, but actually may pose risk for others. And I wanted to show you one example that's associated with fish consumption. And most of us, about 80–85% of us, will get benefits when we get to the higher amounts of fish. There is a subpopulation that has a P4 delta genotype that in fact are placed at increased risk. Gosh, doesn't that make it tough for telling the general public about what to do, because you don't know which population you're in? So we've got to move down this path pretty quickly of understanding what is the genome and how in fact does it get influenced by diet. Unfortunately, we have 2 very, very complex evaluations that have to be done. The genome with about 35,000 genes and probably 8 to 10 million polymorphism, and then 25,000 bioactive components is going to make this exceedingly complex to deal with. We're finding the extremes on both sides of where you're really, really susceptible or really, really at risk, but the rest of it is hard to tease apart at this point. Yeah, you're at least laughing today. Good. All right, so there is more to the story, as I told you from the beginning, than just gene polymorphisms and copy numbers, etc. Epigenetic events are exceedingly important. There are several processes that are within epigenetic DNA methylation, histone, non-coding RNA, and how we put the whole complex together. Let me just tell you a quick story, probably some of the most fundamental stuff that's out there about diet, and that is with the yellow mouse. You know, the yellow mouse, when you breed the yellow mouse, you know what they typically do? They give birth to other little yellow mice. Isn't that phenomenal? Unless you give mom a supplement. And you give mom a supplement during pregnancy, now all of a sudden she gives birth to these little guys. Huh. Changes phenotype by in utero exposure. Wow. Well, that's kind of neat. You and I don't have that gene, so don't think you're going to change your hair color or anything else by taking these supplements. It's a proof of principle. By the way, one of the things you do is you change methylation patterns. What's really important is these guys have a high risk of cancer, diabetes, and obesity. These guys don't. Do you realize in mice, if you overfeed, or rodents in general, if you overfeed them, the offspring have a propensity to overeat for 7 generations? So it's not just you. It's not what your mom ate. It's not what your grandmother ate. It's what your grandmother's grandmother's grandmother ate that is setting a tone for your desire to eat. By the way, starvation takes about 5 generations to get over. There are some real interesting changes that are occurring that we need to know more about. Now, these compounds are associated with methylation. Soybeans have genistein. It brings about the same response. Probably is modifying a nuclear transcription factor that is leading to that phenotypic change. There's one other thing that's on this slide, and that's bisphenol. Our water bottles. Most of the bisphenol in our environment is gone these days, but if you give bisphenol, you actually drive the train back the other direction, and you get more yellowish mice. What's really interesting is if you give bisphenol and genistein, you drive the train back the other way. So diet's important for those environmental factors that may increase our risk of all kinds of disease states. There's another syndrome that is out there called the Kinky Tail, and I just wanted to share it with you because some of us have more kinky tails than others. But one of the things that happens, again, is when you fortify the diet with these supplements, the tail straightens up. It's very interesting how it can change. Changes the phenotype. It's not hair color in this case, but it is, in fact, a change in the phenotype. What's interesting in both of these cases, there's about a 25-30% change in the phenotypic expression, not 100%. So there must be some other factors that are controlling this, and we really don't know what they are at this point. Let me quickly mention one thing that happens in uremic patients. We know that in uremic patients, when you give them the intravenous solution, that we wash out a bunch of stuff. One of the things that you wash out is good old folic acid. And because of that, we know that there is an increase in homocysteine concentration. Homocysteine has been correlated with the risk of heart disease and some cancers, etc. And when you give folic acid, you can actually drive this back down. All right? Classic. What's really interesting, and I think probably the most interesting thing, is that when homocysteine concentrations get high enough, you tend to get double expression of genes. Mother Nature likes to have one dominant gene, not two. And so at these high concentrations, you end up with both the genes now being expressed. When you give homocysteine, now only one of them is expressed. So these are going to give some subtle clues again of some biomarkers that are going to tell us when we should be intervening. And that's something that is going to be the challenge for us, is to find those biomarkers. Okay, so you say at this point I'm showing you a bunch of animal studies or showing you people in a hospital. What about normal individuals? And then here's the case that I find intriguing. It is a sets a tone for histones. And histones, again, are important for regulation of gene expression. If I get too much of these things around, and I can change the genes, and so what I want to do is regulate histone deacetylase activity. So it keeps these things, the acetylations on there, so I allow for normal gene expression. You know, if you take individuals and you give them broccoli, actually broccoli sprouts. Boy, if you don't know this in the food science here, Hopkins has a patent on broccoli sprouts. You know why? The sprouts have 100 times the activity of sulfluorethane, the active component. So maybe these early foods are going to be really important for nutritional value and health benefits. We got to think in those terms. But anyway, if you give a little cupful of these broccoli sprouts, histone deacetylase goes down markedly. You know what? This was done in 3 people. You don't have to have thousands of people to see this thing. And you know what else is important? If you're a broccoli grower, what actually happens is it comes back up after 24 hours. That means you need to eat more broccoli. broccoli growers love that, right? Maybe there's some truth in it. Maybe you don't always want to have histone deacetylase activity at extremely low value. Maybe it is important to eat a variety of foods and intermittently. Excuse me. One of the other factors that modifies histone deacetylase and modifies methylation pattern is actually the total calories. We know a lot of these factors influence the expression of epigenetics, and we're starting to come to grips with, as I've said, obesity is a growing problem in the U.S., and we're going to see more and more cases of changes in expression. Come on, you know, this is, you can laugh, can't you? So, okay, so, you know, I think the issue is that we have a lot of interventions that are out there that are important. We're starting to understand those interventions, and they're going to work in some individuals and not in others. We're starting to identify some of the genes that are so important for a lot of processes to be modified. There's a lot of crosstalk, so it's exceedingly complex. But even with that, we're seeing it in humans, that you can intervene, change the gene expression pattern, change the proliferation that occurs in a case here of prostate cancer, and changes in the proliferation. Lots of genes occurring, lots of ones that are clearly influenced. One of the genes that has been identified that's clearly modified by diet and several dietary components is a nuclear transcription factor called NRF2. This factor is typically associated with removal of foreign compounds. But you know what? It plays a key role in the influence of caloric restriction. So one of the things you should remember from this presentation is that caloric restriction invariably inhibits tumors. However, if you knock out NRF2, caloric restriction no longer inhibits the growth of tumors. So it's fundamental to the process of energetic. And so why is that important? So rather than telling somebody just to cut back on their calories, what you ought to be telling people to do is increase their intake of tomato and broccoli and garlic and curcumin to maximize NRF2 concentration. So one of the other targets that occurred here recently that you may have heard something about is HER2/neu. HER2/neu is associated with recurrence of breast cancer. We have actually a monoclonal antibody that is out there that is actually quite good. And if you give that monoclonal antibody called Herceptin, you can actually get the animals to live longer. They have fewer tumors. Oh, by the way, these are animals that are overexpressing this gene, right? Now, as Paul Harvey would say, there's more to this story. Look at that. This is a story of intervention using fish oil in these animals that are overexpressing HER2/neu. And if you look closely at these data, I could actually superimpose them, couldn't I? Huh, that means the nutrients is as good as the drug? Actually, I was asked that question in Europe not too long ago. A man said to me, are you telling me that fish is just as good as this monoclonal antibody drug? And I said, if you're rodent, I don't know about humans. And he said, no, seriously, I want to ask because, you know what? In Europe, we can't bring Herceptin in. It's too expensive. So they're looking for alternatives. We need to do this study. There is no question about that in humans that have the overexpression of genes, and I think it could be done. But that's where we're headed, is to the findings. I've got about 10, 15 more minutes. I'm okay? Yeah? Oh, yeah. You haven't thrown anything yet. So. Okay, so, you know, one of the things, we've talked somewhat generally up to this point. I want to make sure that you understand that we don't quite know what we're talking about when it comes to diet and cancer prevention. And the reason is that it's all muddled together. We don't really know if we're talking about maintaining a normal cell and keeping a normal function, or we're preventing the normal cell from becoming an abnormal cell, or we're in fact modifying the abnormal cell. And so I thought, I'm going to give you two examples which will kind of knock your socks off, I hope. One is good old indole 3-carbinol that's found in cabbage. You know, if I put endo-3-carbinol on some tumor cells, it causes them to not grow very well. They're not happy campers. But if I put it on normal cells, they bebop along, they divide, they have all these great times. And so people said, why could that happen? It actually turns out that one of the primary reasons is a difference in a factor that's associated with cell proliferation, cell division. It's actually this transcription factor, this factor, this cyclin, that in normal cells is fairly long, and in neoplastic cells is short. Well, how do you shorten a cyclin molecule? You do that by a protease enzyme, and in fact, in this case, it is elastase. And one of the primary reasons why, in fact, you get a benefit in neoplastic cells and not in normal cells is that you inhibit elastase activity. You then cause the cyclin molecule to be longer, and that slows down cell division. Isn't that nice? So you kill the tumor or you suppress the tumor, not the patient. Super, right? Okay, there's one other example, and that's with my old favorite food of garlic. Garlic, we know, if you give it to normal cells, it does virtually nothing. If you get high enough with any of these nutrients, you know, you hit them with a Mack truck, they're going to die, right? Anything will. But if you do more physiological concentration, tumor cells are much, much more susceptible than normal cells. And so the question is, why would that occur? Now, when you think of garlic, I think of sulfur, I think of SH groups, I think, yeah, stinks, and werewolves and all those things. But that, neat stuff. But it actually turns out those sulfur compounds are probably modifying thiol switches in the cell. And one of the things that they're actually doing is they're increasing radical formation in tumor cells. Whoa! I thought SH groups were antioxidant. Turns out these compounds are pro-oxidant. When you give do I go back? When you give garlic compounds that include diallyl trisulfide, you actually increase radical formation. And the radical formation, interestingly, comes from iron that's in ferritin. Have you heard of the Fenton reaction? So what you do in a tumor cell is you precipitate the Fenton reaction, which causes oxidative damage. And if you block oxidative damage, you block the anti-cancer effects of garlic. Isn't that a neat story? So it's not only that these compounds are serving as antioxidants, it's serving as pro-oxidant. Same thing holds for flavonoids and several of the other compounds that are in our food supply. All right, so up to this point, I've given you a lot of information about the omics in general. I thought maybe I need to sit back and make sure you understand that in many cases these nutrients are functioning when there's an insult. Carcinogen, a virus, a bacteria, or something. As a proof of principle, here's one with HPV associated with cervical cancer. Animal model. If you have this virus and you introduce and you have estrogen, which is normal, you get proliferation. And when you get proliferation, you put in endo-3-carbinol, you can inhibit the proliferation. So it blocks the action of the virus. But if I don't have HPV and I have estrogen and I put in endo, I don't see anything. So again, these food items have specificity that is caused by the insult that the individual is facing. Now, one of the insults that you and I are facing is obesity. And one of the nutrients that is out there that may actually be causing some of the increased risk is good old vitamin D. As we get heavier, vitamin D concentrations go down. So is there any relationship with vitamin D? You bet. We're seeing more and more cases of low vitamin D status which is questionable how we define vitamin D status. But low status, at least the, what I call again the bottom feeders versus those other ones, there is a increase in risk in those. Look at the variability in response that they're talking about with vitamin D and decreasing the risk of colorectal cancer. That's, by the way, where the strongest evidence is. They're suggesting to get about a 50% reduction, you need somewhere close to 2,000 international units. Most of us are around 400 to 800 units, unless we're sun goddesses. Look at the variability. Do you feel warm and fuzzy with that? I don't. By the way, the upper level for vitamin D is set by the Academy is 2,000. Cool. Raises issues, doesn't it? Wait a minute. Now, wait a minute. For breast cancer, it's worse. They're suggesting somewhere around 3,200 IUs to reduce risk by 50%. I think it's an interesting hypothesis. I think there is something to it. I think the bottom feeders do need some help. But I'm not sure we know how far we should go. There is evidence, 3 minutes, okay? There is evidence that introduction to vitamin D and calcium will have some benefits. This is a study that was conducted out of Creighton. It's a nice study. It was actually done to improve the bone of women, elderly women. Didn't do anything. Secondary analysis showed a change in risk of cancer at all sites. If you look at closely at this data, you see there's one treatment that's missing. That's vitamin D alone. The important thing is it's secondary analysis. And so it's hard to say it's factual with secondary analysis. So you know what that means at NIH? A new grant. So this individual has a new grant to complete, to conduct another study. Well, quickly, just let me say to you, it's not vitamin D alone. There's some interactions with soybeans that occur. We now know some mechanisms by which that can occur. And so there may again be some blends of foods that are going to be most important. I've got to show you 2 slides, whether I'm too late or not. And that is, listen, we don't know the optimum, and we have to raise concerns about it. This is some data that's out there on prostate cancer. And if you look at it very closely, you see a U-shaped curve that is there. I said some people will get a lot of benefits, others might be placed at risk. That's happening more and more frequently with several nutrients. Beware. Inappropriate excessive intake can put us in a more vulnerable condition. Timing is important. We know in animals, if you give folic acid early for susceptible animals, you can inhibit tumor. If you give it late, you can enhance it. Just let me tell you the biggest study we have going on right now in us. We are fortifying the food supply with folic acid. And look what happened when we start fortifying. Colorectal cancer risk went up. Now, they're still coming down, but that is probably a vulnerable group that has an increased risk because we actually are fortifying this food supply. And maybe we can, with time, identify that vulnerable population and who should minimize the intake of red products that are being fortified. When I get there, if I can, well, I think it's telling me to stop because it doesn't want me to advance. But I want to show you this one slide. I love it. This is, you know, if you ask for my slide set, I know it's going to be for this slide. I have actually shown you a lot of information today. I've really tried to get you to think about how important diet is. I hope I've left the impression with you that diet is important, but we cannot generalize. We actually have to step back and start talking about individuality and that one size does not fit all. And I will just tell you that on October 21st through 23rd, we're having a big meeting at NIH to talk about nutrigenetics and nutrigenomics. There will be publications coming from that if you're not able to attend. And I'm going to show you this last slide. This is where I think we are. We need to identify what are the active agents, how much we need to get a response, and the site of action and the susceptibility factor. Thank you very, very much.
Social pressures.